T-1 minute, people. Okay, so it's me doing the intro, outro, and after I do the intro, handing over to Max, yeah?
Yeah.
And I hand over on the types slide. Cool, cool, cool.
Just to clarify, to Hannan, right? And then you take the types.
Yes, I will take care of the types.
So are we gonna present and then have question sessions?
Yep. Righto, it is 2 o'clock. Are we ready? I'll take that silence as a yes. Okay, fantastic. Welcome to Jina's Engineering All Hands for 8th of December 2020. It's good to have you all here, either watching on Zoom or in YouTube land or wherever you may be. So, first up, what the heck is Engineering All Hands? So, this is where we, as Jina, open up to the community. I mean, hell, we're open to our community anyway, but this is where we put our ugly mugs on your screen and you get to see us in all our glory. So it's a summary of what's happening at Jina, the goals we're striving towards, and kind of a show and tell. So you'll see some of the new and funky stuff in action. And yeah, we love your questions. So we'll have a section at the end of this, or maybe in the middle, depending on how time goes. So you can ask your questions there or put them in the Q&A. And yeah. So when and where is it? So second Tuesday of every month from 2 p.m. to 3:30 p.m. CET and right here on Zoom. So if you're watching this on YouTube, you can go to our website at Jina.ai and you can find the Zoom link there. One of the big things we're working on at the moment is support for the newest version of Python, Python 3.9, and we would really love the help of any community members who can, yeah, give us a hand. Last time we also put out a call for help with Windows support, but we're now running on Windows Subsystem for Linux version 2, so yay. We've got some upcoming events, and man, it is a packed schedule. So on December 11th, we've got Rituja speaking at NeurIPS. I hope I'm saying that right. We've got Joanne speaking at Pi Day Barcelona on the 12th. Myself and Han speaking at Cloud Native Kitchen on the 16th. And Lucia speaking at the Open Core Summit on sometime between the 16th and the 18th. I'm sure she'll clarify in the Q&A. And on December 21st, we're releasing 0.9.0. So for any info on events, go to Jina.ai/events or follow us on LinkedIn or Twitter. And yeah, that's how you can keep up with us anyway. We also post upcoming events and things to Slack, and we would love you to join us there to ask questions or just shoot the breeze. So for that, you can go to slack.jina.ai. So without further ado, that's my part done for now. So I'll hand it over to our wonderful engineering team who will start the show and tell section.
Okay. Hello, everyone. Am I hearable?
Yep, loud and clear now.
Yeah. So welcome again to our engineering all hands. So this is Nan, the CTO of Jina AI. So for this all hands, I will start with introduce one of the highlight in Jina 0.8. That is the primitive type. So if you have already played around with Jina, you will be familiar with the concept of a document. in Jina, a document is the most basic element to represent data. When the user sends a request to Jina, no matter it is an index request or it is a search request, it always consists one or more documents. And these documents are passed along the flow and then processed by each pod in this flow. The overall definition of the document, you can find that here. Can you still see my screen?
Mm-hmm.
Yes.
We're still seeing the slide.
Okay, let me check. Will you share? Mm-hmm. No, here you are. Yeah. So you can always find the definition of a document here in the Jina.proto. So we use the protobuf to define the overall structures of the document. I put it here. Yes. And yeah, as you can see here in the protobuf, we define different fields for the document. And yeah, as one of the most basic data structure in Jina, document is widely used everywhere in Jina. And it's so important that we decide to introduce document itself as a primitive type in Jina. So this will make life way easier. Let's start coding. For example, before 0.8, if you want to create a document, you need to be aware of how the document proto is defined, and you need to know a little bit about protobuf. So basically, you have to understand what is coded here. And if you have no idea about what protobuf is, you might get freaked out by this point. And now so for example, in the version in the Jina before 0.8, if you want to create a document, basically what you need is here we define a dummy image with some random number, and then you need to introduce Jina proto. You need to use the Jina proto PB2, and the help function defined in help us to convert the array into protobuf. Then you can define a document proto. Here, you need to say, hey, I want to assign this array where we define here to our document. And you can't do that directly because the array is defined as a numpy array. And in document, we need to convert it to the structure that we define in the protobuf. Then you need to use this function, array to PB. While now with the document as one of the primitive type in Jina, the life becomes way easier. Now what you need is simply from Jina import document. And then you say, hey, I want to create a document. And then I want to assign the property blob to the image. That's it. Now you can check. You can check the document. It has the property of blob properly defined. And well, we actually offered multiple ways to construct a document. You can also construct a document. I mean, the primary way to construct a document is from the dictionary. Now we define the dictionary. Hello world. And then we can create a document from this dictionary directly. We can check the document. It has one field. It has the text field assigned to the value of the dictionary. The second way to construct a document is using the JSON string. So now let's create a JSON string. So we create a new document from this JSON string. You can say document, and I can use a JSON string from our previous document. Oops, something goes wrong. Sorry, the full dict. Okay. Now we can check the document we create from the JSON string. Yeah. And if you want to go further deeper, and we can also create a document from the document proto, which we had before. So we can define a document. We can now we first generate the document proto. I hope you still remember here. In the Jina proto, we actually defined the structure document proto here. And from the document, we actually offer one way to access the proto object. You can check here, has BB project. And this, we can check the tab, the PP. We can check the tab of it. It's actually the document proto where we used here to create the document before 0.8. And now we can create a new document from this document proto. Ta-da! So you can check. It's actually the same as before. If you are familiar with Proto tab, you will know that the Proto buff is actually widely used for its high efficiency of serialization and deserialization, and sometimes it's actually when it's transferred across the network, it's actually using the binary format. You can also create a document using the binary format of the protobuf. So we can say, I want to create a document with the binary format, and this time I'm using the binary representation of the document proto. Simply say .pb serialize to string. We can check again whether this document is properly created. So basically, they are the main method how you can create, how you can construct a document with this primitive type. It's becoming really easier to set and get properties of a document. As we have already seen that for a document, it has two properties that is really important. One is text, and the other is blob. So besides text and blob, there's another property in the document called buffer. These three properties are used to represent the content of the document. But remember, every time only one of them is set. So for example, now we have the text. We have the text which have the blob property. Let's print it out. All right. So now we have the text property set, and then I can say, hey, I want to set the blob property to the image. Wait. I want to set the blob property to the image. Now, if we check the text again, now its text is empty. And the blob is set properly to the image array. Why this is the case? Because in Jina, we actually we have three types to represent data, as we said before. We have text, blob, and buffer. And every time only one of them is used to represent data. The logic is that these three properties are representing the same information, but in different formats. Which format is which property will be used highly depends on your use case. For example, if you are using the text data, then you will use the document. You will use the text property to represent the data. And if you want to represent the images or the videos, which can be easily represented by a matrix, then the blob property is recommended. For the rest, for the other types of data, you might have no idea how to represent it properly. Then you will be using the buffer property to represent the data. Well, you might find a little bit annoying to remember different types of data. No worry about that. In Jina, we actually offered a more naive way to access the content of the data. It's called content property. Now we can simply type document content. Then you will find the way you will find out how the data is represented in that document. Now we're using the blob to represent the data, and that's why when we access the content property, it will show up the blob. It will show up the value of the blob property. And if we go back to say, hey, I want to set up the text. Now, if you check the content again, it will actually show up the value of the text property. In general, as you have already seen, by introducing the primitive type document, we are making Jina really easy to use and really easy to extend. Before we moving into the other properties of the document, let's look at the code. Okay. let's look at how the document is implemented in Jina. Here, under the tabs folder and document folder, here we define the document class. As you can see here, in init function, the main magic happens here. Oops. Yeah, so under the hood, in the document class, we actually wrap up the document proto class. And this is why basically the document is a wrap up of the document proto. And while in the document class, we actually offer a view of the document proto itself instead of copying the whole data. And plus, you will notice in the here, you might say then it becomes really tedious to copy paste and to wrap up all the properties of document proto. Actually, what we did in the document class is that we only wrap up the properties of the document proto. We didn't wrap up everything. We just wrap up the properties that need extra logic. For example, content. For the rest, it will automatically fall back to the properties of document proto, as you can see here. Okay, now we can move on to the next primitive tab in Jina. Previously, we have talked about the document. Now the question is, how can we present a sequence of document? Yeah, a naive way would be using the list, but in Jina, we actually want to make it, we actually build a container class for a sequence of document. You can check from Jina. We call it the document site. Now we can create a document site. First, we create two documents. And then we can create the document site in the very Pythonic way. You can check. Now you can access the document in the document site easily with the index. Well, one reason to create the document site is because in Jina we actually offered a way to group up all the documents. In the documents, one highlight of the document in Jina is that we offer the recursive structure to represent data. If you haven't heard about the recursive structure in Jina, you're referred to the previous video. I think Han has already mentioned this topic before. Now, let's look at, the recursive structure in Jina, including two parts. So we have the we have the chunks, and we also there are two places that Jina uses recursive structure. One is the chunks, and the other is the matches. Now let's look at how we access the chunks with the new primitive type. Now now we first create two chunks. So in Jina, the chunks also represent each chunk is represented by a document. And now we create two chunks. We can check the document we created before. The chunks, oops. We can break the chunks, it's empty. Now we can check the length, so it's empty. And we can check, now we can add the chunks we created to this document. Yeah, now we can check whether these chunks are properly added. So you can see the chunks are added to the document. If you check the tab of the chunks, see here it's actually another primitive tab called chunk set. The chunk set is actually inherited. You can find here. Here, as you can see, the class chunk set is actually inherited from the document set. The difference is that it offers some dedicated properties that is widely used when you are handling with chunks. One of them is a parent dog. So the parent dog is used to access the parent dog is used to quickly access the parent of all these chunks. I mean, in this case, it's a bit dummy because we are actually going from the document level to the chunks level and then access back to the document level. It's a bit dummy here, but in the real use cases, sometimes you only have the chunks and you don't have access to, if you want to have access to the parent document from the chunks level, it is a bit tricky before, and now it's way easier. Similarly, in the document, we also have the matches. As you can see, type of matches is defined as another primitive type called match set. And the similar as the chunk set, match set also offers some properties that makes the usage of matches easier. We can have a quick look here. Yeah. So instead of the parent ID in the match set, is actually offer a property called reference dog. So this is also widely used when people are using the matches. So this property actually tell you where, from which chunks this match is generated. Yeah. Okay. And yeah, Next, we can also talk about the multimodal document. As in Jina itself is designed to build multimodal and cross-modal search system, and therefore we also introduced the multimodal document as one of the primitive type. So from Jina tabs, document, multimodal, we can import the multimodal document. Yeah, the multimodal document is quite useful because it's actually combine the chunks from different modality. For example, now we create a multimodal document, and the way we create it is to to pass the argument called modality content map. Then I can have one modality. Like, for example, now I want to create a multimodal document, modal document for an article, and one modality can be the author, and the author can be represented by a dummy vector. So we have a author vector. And then I say the author should be the author vector. And meanwhile, I can have another modality called the text. And I can give some random text, hello world. Now we can check the modalities of the multimodal document. Yeah, and you can also access the different modalities easily by the name of the modality. Oh. Did I type something wrong? Ah, sorry. Yeah. If you, I mean, a more native way to use the multimodal document would be you can create a document that equipped it with both images and text, and then during query you can query you can search this document by using both the images and text. We have one example in our example repository. If you have interest with the multimodal search, feel free to check it out. Okay. Well, yeah. So I think this is about the end of the introduction of tabs. I mean, document. So basically, what we have already seen here is document as one of the primitive type. And beyond the document, we also offered several container classes, including the document site, the chunk site, the mesh site, and we also extend the document into the multimodal document. As you have seen, the primitive type, by introduction, the primitive type, it makes Jina really easy to extend and easier to use. But besides document, actually, we also introduce the other primitive types. You can find a more detailed introduction in Hans' blog. So here, yeah, this figure provides a better view of the primitive type. yeah, basically besides the document, we also have the query line ND array as the the subtype of the ND array, including the sparse array and dense ND array. All these are the primitive. These four are the other primitive types introducing together with the document. Yeah, and also we have the primitive type for request and message. Besides this primitive type, we also have this container class, including the document side and the query line side. For the more details, you can check out Hans' blog for the further reading. Okay, I think that's the introduction about types. All in all, the primitive types in Jina offers a better representation of the low-level data representation, and this will makes using Jina either simpler and faster, and also make Jina really easy to extend. Yeah. Okay, that's the part for primitive types.
Then it's my part to take over.
Okay.
And I will share my screen. Can you see it?
Yes.
Perfect. So I will directly continue where Nan left off with document structure and traversal. So now we have our primitive type and we have our document, and now we want to do something on this document. And therefore, we already had beforehand the traversal, the option to traverse somehow document trees. And for this, I want to make a short recapitulation what document trees are, and then show how the traversal works now, and how you can somehow combine this writing documents and use the traversal. So as Nan already said, the concept of chunks should be now quite familiar. When we have a document, let's say this document somehow has a text. This is my first document. It consists of 4 sentences. You can also find multiple paragraphs. Let's play around. And now chunks could be, for example, when I split my document into the paragraphs. If I want to do this, I want to split the root document somehow by the new line character. And perhaps by a synthesizer, what this means will somehow, you will find out in a moment. Another way to split this document into chunks would also be by sentence. It's another option. Then we would sententize the root just with all punctuation cars and somehow not white spaces, new lines. And now there's the next possibility. You could split first by paragraphs and then chunk down the paragraphs into sentences. Then you have multiple layers of chunks. And then you would first split the root by new line, and afterwards split the chunks into chunks by punctuation characters. This is somehow what Nan showed you. You can add chunks, and I will show you how you can do this programmatically and understand how to set this up properly. But before we do this, there is a second type, matches, and matches somehow work the same way. We might have a root document, and we might have matches, which belong to this root document. And now we can think of all the chunks somehow of our root document as one chunk family. And then all the chunks of one of these chunks also as one chunk family. And we can somehow address them by our document.chunks, or when we want to address down here, our document.chunks, which brings us to this family, the last element, and then again chunks we get down there. And when we think of this, we can name somehow our nodes, somehow node families. So when we have a root document, we can name all of the chunks with C, and all of the chunks with CC, and all of the matches of our chunks with CM. And the same thing somehow on the other side, we can name the matches by M, the chunks of the matches by MC, and so on. And then we can somehow address a family and can say, okay, please do something with this family. So when we said in the beginning, we want to first split the root, we can say, please do the sentencizing on the root, then the paragraph splitting on the root, and then do the sentence splitting on the chunks. And that's why we somehow name this this node families in order to be able to explicitly do something on the family level, run an executor there. And now I want to show you how this works in practice. So you should be quite familiar now with, in the first thing, I just create a document. This is some of the same document you just saw. It's 2 sentences here, 2 sentences there, and 2 new lines in between. So it's a function to get me new documents that whenever I need a new document somehow in the further script, I get really a fresh one and don't fiddle around with the same. So I can define chunks, as you see here. This would be somehow, or when we split by hand, our first splitting, I create one chunk with the content of the first, a second chunk with the content of the second, and then I add these 2 chunks to our document. And when I do this, I see our document with the text and the 2 chunks. So that's somewhat the very same that Nan just showed you, just with different text in there, and I now have document. And now, when I print it, the printing doesn't look too nice. What I can also say is, okay, please print me the chunks of the document. And for this, I can define a print function. This is a bit shallow now, but we do it as the first example. We want to show what happens. So I have a print function, which accepts a document. Then I can somehow say to the document, please go into all the chunks. So traverse all the chunks and call the print document function on these chunks. And when I execute this, I get the content of both chunks. To make this a bit more explicit, let's do something like that. These are really 2 calls. This function is called twice. We see here now, yeah, each chunk is somehow displayed once. So what happens with this traverse function? It goes to all the chunks of the document because we define here the chunks. This is the node family chunk and calls the print doc function. And now we can also think of, okay, let's have a split by dot function. Let's implement this. So we have, we want to get somehow splitted sentences. So now we want to split a paragraph. This d.text.split, and we just split for the sake of simplicity by dot. And then we say for chunk sent in splitted sentences. Then we first check if it's not empty, or no, we don't even have to check this. Then we can say chunks.add, and then we can say document with content equals sentence. So what happens now? We first create somehow the new chunk. Let's make this a little bit different. Chunk. We first create the new chunk with this document, and then we add this chunk somehow to the document. And now we can say, please traverse. And now we don't traverse on the main document, but we traverse on the chunks of this document. So this function should now be called for each chunk. And afterwards, let's see what we have afterwards. And then print document. And what we see, we have the original document down here. Then we have one chunk, where the content of this one chunk is somehow the 2 sentences. And the content of the chunks are the sentences that we expect there. The same holds true for the first chunk, where we also have somehow that this is the text, and this is split down into this chunk, and since there was somehow something more, we haven't checked for empty spaces also in this chunk, because there was something behind the last dot. And this already shows us, okay, perhaps we shouldn't write the splitting by like this, but in Jina we should have some functionality which does the synthesizing for us at the splitting, and this is why we have a synthesizer. And now I want to show you somehow how we can synthesize things. And the principle, we can usually in Jina you set up all your flow via YAML files, but since I wanted to show it in here, I will show how to do it just via Python, how you can also get synthesizers via Python. So here, my basics, we first use the basic synthesizer. And now look at this code. Here I define our flow. And this, the reason why I define the flows on our document, I want to run the synthesizer. And so I first get a flow, then I call the add, and add a synthesizer here. And I use my basic synthesizer, which is just somehow, which this string somehow tells Jina to get it. And then I start the flow and call index on this flow, which is just somehow do whatever the flow does on these documents that I give you. And I give them just the document once, fresh document, and have a callback for printing that in the end I can see something. Let's see what we will see. So the flow runs, and in the end, this is somehow the printing that comes out. I get the document has 4 chunks. So our basic synthesizer splits by each punctuation chars and character and by end of line and skips all the empty chunks. And that's why we got somehow 4 empty ones. Okay, that's nice. We now can somehow also say, please only split on new line sentence on new lines, which is somehow synthesizer where we explicitly said, okay, our punctuation characters is only the new line and nothing else. And when I now use this one and run it again, I see, okay, I get 2 chunks and both of them are the paragraphs. Also kind of nice. But now comes, okay, I wanted to, apparently, one of the things I wanted to see is this, that I have chunks and chunks again, and do this in Jina programmatically. And now I will write a synthesizer which does exactly this. So I write now, or the different way, I need to write 2 synthesizers. I first need to split the root document, and afterwards I need to split the paragraphs again. So splitting the root document, the 2 paragraphs I already have, but now I somehow have to also need one which synthesizer which splits the sentences once again. So I here got me a second synthesizer which does it. How it does, I will show in a second. First, let's see how in the flow we somehow add a second synthesizer. So this will, the first one, I just add a second one. And the first one will be the generate paragraphs. And the second one will be, is apparently a synthesizer. So I just say to do it twice. And for the second, I use the one that I defined down here. And so the first one will do what we had before, splitting into paragraphs, and the second into sentences. And for splitting into sentences, we will now look what happens. So in the end, it's again a synthesizer, which takes all the punctuation characters that are there, dot, comma, not comma, dot, exclamation mark, question mark, and all the weird things where even the turned around question mark and all these characters will take care of all these. And then we say, okay, please run this synthesizer on different traversal paths. And we just want to apply it on the chunks. This is some of the currently the syntax that we need to define a parameter that defines where to run the traversal. That may change in the future and become a little bit nicer, but for now, this is how we do it. And so we say, okay, please run this synthesizer on chunks. And when I run this now, we get that we have first the first chunk, which is what we wanted. And then we have the chunk 0.0, which is the first sentence, the second sentence. And then we have the second chunk, which is also split into sentences. So this is one way of doing it and defining when we have an executor where the executor should somehow do something and apply. Yes, I think that's all I wanted to show. Somehow how you use the traversal once when you directly want to traverse on a document, either for printing when you get results back from your flow, or from or for also building the document itself in the initial phase. Therefore, this is a traverse somehow on the document where you call document.traverse. Or how you somehow the same concept applies when you use synthesizer. It's the very same traversal that is called. It's also somehow called on the document, just implicitly by Jina when you define down here the traversal path for drivers. Apparently, this is a segment driver where you define the traversal path. And I want to connect some of the 2 dots of you have a document and you have traversal and how all of this works together. That's all. And if you have any questions, I think the next slide is the community question slides, either to none to me on the specific topics or also on further topics. So now it's time to ask question.
Come on, people, don't be shy. Oh, I gotta say, it's good to see all the new, well, I want to say all the new faces here, but some of these are just initials in a little colored box. So yes, it's good to see all these new little initials in colored boxes on Zoom that have joined us. So yeah, good to see you, Deepam and Saimar and Sridata and Stefan.
Hi there.
Hey Sai, how's it going?
Good. How's it going?
All good here?
I think I should at least just pop on and say hi because you just said hi. I have to like unmute myself.
See, I put you on the spot.
I'm very new to the community, so I don't have any specific question to ask. It's just like want to see like what's going on here. That's it.
So how did you find out about Jina?
Like resource from my friends.
Your friends have excellent taste. You should tell them that.
Yeah, yes, it definitely is.
And yeah, do you have any projects in mind you want to build with Jina?
Not really. I checked your, sorry, no offense, just like, because I'm very new to the whole community thing. So just like, I don't have any specific project right now which I think I could probably use Jina. But yeah, it's definitely like looks quite interesting. I'm gonna look through your GitHub and try to see if there's any low-hanging fruits I can borrow from.
Good stuff. And yeah, if you have any questions or comments or feedback, just ping us on Slack.
You have a Slack channel? Like the
Yes, you can go to slack.jina.ai in your browser and that should redirect you to our channel.
Oh, all right, cool, good to know.
Where are you calling from anyway?
Working from home. I mean, physically I'm in Berlin.
Oh, nice. As are many of us.
I saw it's like you have like 13 employees currently based in Berlin, right?
Yeah, quite a few of us here.
Yeah, I could be mistaken. I didn't really do my homework.
Yeah, it's difficult to do a head count, what with everyone working from home these days.
Yeah, exactly. And I saw your events like last night, like when I talked to my friend, I said, this is a cool company, we should check it out. Then I saw the upcoming events. I canceled a meeting with my boss so I can attend your engineer all hands.
You made the right call.
Yeah, all right. I mean, since like, I don't know if if I'm the only one here who's not from Jina, am I?
No, we've got a few others. I believe Deepam and Shri and Stefan are also not with Jina. But hey, we're growing so quick. We keep
Yeah, but I mean, if I may ask a few things, very probably stupid questions.
No such thing as well, okay, there are stupid questions, but
all right.
no, none of your questions are going to be stupid, I'm sure. I was thinking like, do giraffes like to eat jelly? It's a stupid one, but that's irrelevant. But fire away, that's what we're here for.
All right, so like I missed the first 30 minutes. So you probably already have given a short introduction like of everything. But since I missed it, I'm wondering, like what is the primary benefits of using Jina? Like if you are advertising to your stakeholders, your customers, like do you have like a 3 main points? Like what can people use about that?
I will say that right now we're not in the looking for customers phase. We're still very much under development and still working with developers to build out the ecosystem and build Jina. But some of the key advantages are, I mean, compared to conventional search. So if you're doing conventional text search, you have to write quite a complicated pipeline to break down the text, to parse it, to deal with misspellings and things and catch edge cases. Because we're using machine learning models to do that, it takes a lot of the headaches away, because these models are pre-trained to do just that. And because we're working with machine learning models, you could use, if you want to search images instead, you could just use a different model and plug that into your flow, and then you could feed in images. But Lucia will have
Yeah, I mean, I can give you the, you're asking for the PM version of value proposition, and I can give you that. There's actually, I'm going to be rude and I'm going to present for just a second. But basically we have, do you guys see my screen? No, we don't. Do you?
Mm-hmm. Yep.
Okay. Sorry. Really quick, to answer your question, the 4 main pain points that we're solving is universality, like universal. So we're striving to allow for a lot of different data inputs, as well as supporting a lot of different AI machine learning models in the background and libraries. So that is one main way of how Jina adds value, because you can just use it in just about any type of environment without thinking about different or add-on dependencies and requirements. Cloud nativeness is another key value proposition, especially when you look at the overall architecture and structure of Jina and how the whole thing is built up. You will find a lot of these very neat ways of how we kind of proactively thought about distributed systems, cloud systems. And so I think you can see, you know, the containerization of all the different components of Jina in the flow, the microservice structure. You can see a lot of that. What Alex talked about is in the time saver one, basically buckets. So we see a lot of the potential initial customers thinking a lot about time saving and kind of taking away the headache of having to stitch together different systems. So what we see a lot on the use case side is that you have some sort of Elasticsearch system, and then you try to kind of combine or include indexers and encoders, you know, things like a NOI indexer, or, you know, like a FICE scan, those type of different models that you kind of have to stitch together yourself. You see a lot of that. And then and obviously Jina adds value because it's time saving in that way, the framework and how it's built. And plug and play or extensibility is when you do go and have a look at the hub. We do have a lot of out-of-the-box hub pods that you can use in order to create something that is more specific for your use case. So either you can go to the examples, or you can go and look into the hub to kind of find very important or very well-equipped pods for different use cases, like image search, or like the main spaces, image, text, whatever you want. So this is the, I think if you want to look for the key value propositions without going into the feature roadmap or the feature list, this would be the 4 features that, or the four value propositions that we do have for Jina for adopting.
Right. I see. Thanks.
You're welcome.
Can I ask another question?
Fire away.
My laptop is not exactly working. Wait. Oh, yeah. All right. Do you have your own algorithm for the new iterative neural search as you have advertised?
If we have what?
Do you have your own algorithm doing that?
Our own algorithm?
Yeah.
So what exactly by algorithm you mean? You mean the vector indexing part, or kind of cross-modal or multimodal encoding mechanism?
So, all right. As like so far as what I have understand, like you're building models mainly for searching, right? That is the main functionality you're trying to provide. And those machine learning models, I was wondering, like, to deep down the most granular level, do you have your own algorithms, or it's just like putting everything together, make a whole pipeline, make each individual part like as optimized as possible, like to combine everything to make your own recipe? Or rather than that, you actually have your core technique for the searching functionality? Did I make myself clear? I saw the confusion on my face. Just
Yes.
all right, cool. Thanks.
I can give you the high level and then engineers can jump in, but the very high level answer is no, we don't have our own algorithms because we're not doing algorithms. We're doing frameworks and design patterns, which means it's much rather, I know people are going to hate me for saying this, but much rather think of the way of how you actually build search, not the image recognition model. So we're leveraging pre-trained models that come from all kinds of different areas. They come from other big companies that do quite a lot of extensive research in these areas. They come from research directly. And what Jina helps doing is basically bridging that gap between the research and being able to use it in search pipeline and production. But we're not creating our own. We're creating, let's say, the Jina representation. So you can use it in a Jina search pipeline, but we're not recreating any type of algorithms ourselves.
All right, thank you. Then, all right, it's a little bit overwhelming. Just give me a second.
I can imagine. We've all been there. It's the conceptual part is a big hump to take. So
yeah, right. I literally have like hundreds of questions right now in my head. It's like boom. Okay, what is the primary role I'm gonna ask? I hope it's not offending any of you. I'm just like, I have noticed this is like a startup company, like quite new, fresh. You know, it's like very young, innovative, energetic, and just like from what you have just described, I feel like it's like the possible business value in the future is probably like for certain big companies, like using that internally in this company for the searching functionality. And since you're using pre-trained model, I'm just wondering, how do you update that? If you don't have the capacity to control, to manipulate the pre-trained model, because you are just like borrowing that, right? Like, how do you update that with a real time, like not real time, but with the real data specific to your potential customers? Like for example, if I want to use Jina right now in my company, you have been using pre-trained model. I'm pretty sure it does not have all the info I wanted for my own environment, right? Then how would I gonna use it in this case?
So in this case, most probably you, if you want to somehow steer this model on your use case, you might take the output of the model and train your own layers upon this. So with your whatever data you have for training, if you have, I'm not sure what is your use case, but let's say you have an online shop, and you have tracking data, and you somehow have a search system and want to steer the output of the model towards your system, you might train another layer upon the pre-trained model, and then use also this trained layer on your side together with Jina again. So then the whole serving of the model again is on Jina's side. So when you have this model, you can, and you use, for example, a model which is similar to Torch transformers, you can, or to whatever model you have, where we have already the plug and play capabilities, you can just drop in your new model and somehow can use Jina again for searching. And you somehow can leverage this when you would do something with a similar technology. Until now, you somehow need to first extract from your models the encodings, then you would need to write this encoding to some database, then you would need to write somehow how the target distance from your search to your objects that you search for are somehow computed. So you would have to add a lot of different points, which all can somehow must be done customly. And with Jina, you just somehow can jump in your freshly trained model that you bring yourself. So, and it might be at some point in time that we also give you the possibility to train directly a model from Jina. But on the other hand, we also have currently building the capability that you can take all the models that are when you use, for example, for text encoding, transformer encoder from Torch, which has quite a lot of parameters which you can play around to optimize it for your explicit data set. You can somehow have an optimizer which you can give an evaluation data set, and then this optimizer will choose the best parameters for your use case. And so then it's not just dump, okay, I took a pre-trained model and plug it in, but I also even if you have a pre-trained model, you have a lot of different parameters which you can play around with. You can somehow optimize and get the best parameters with this pre-trained model in the near future.
Okay, I see. Thank you.
I have another question adding to that, if I can.
Sure, go ahead.
Yeah. So the method you mentioned is like when you train a normal model with the data set which is the normal data set for the particular model, the features it learns is the image, right? Like how, like for me to optimize that in the latent space, like all the similar samples are together. Like, is there any way that I could get the insight from Jina framework? Like, yeah, like say like you have a autoencoder and you can visualize the latent space, like latent embeddings, which the indexer will use to get the best matches, right? So is there any, like did you think about any, like say like TensorBoard visualizer to just show so that I can tune my parameters such a way that the clusterings are better, or is there any metric that you guys provide? Is the question clear? What I was asking?
Yeah, I'm not sure somehow if you already have an evaluation metric in your mind, then you can bring your own evaluation metric, your own somehow test data set, and evaluate also with Jina. Then you somehow can plug in the model, the evaluation data set, and when you have different parameters to play around at this model somehow and get the best one. Or also if you have visualization somehow in mind that you want to use, you can also plug it into Jina. But I'm not exactly sure if I got your question right.
So basically, like if one has to do some specific task, they have to do all the training outside, and they just have to get the encoder which they want and put it to the framework, right? Like everything has to be done outside Jina.
The training, yes, until now. That might change in the future. So we have somehow have also the long-term vision that we might include this in Jina, but not for now. For now, you somehow have to bring your own model, yes.
Cool.
Or take a pre-trained one.
Yeah. Thanks.
Any more?
Hi, I'm Deepam, and I had a question regarding classifiers. So I was building a flow where the classifier okay, right now the base predictor class assumes that it will use the encodings received from the encoder class, but the classifier that I'm using requires it to re-encode the sentence, and it's basically like using another encoding just to generate the tags. So is there a better way to use the base predict driver, or are you guys thinking of adding a functionality into the base predict driver so that the user can switch between using the encodings from the encoder class and regenerating the encodings using some executor class?
So basically, your question is, for your classifier, you want to use the other embeddings instead of the embedding of the document.
Correct. Yes.
Mm.
And base predict driver requires you to use the embeddings passed by the encoder. So is there a better way to use, or is there a better way to have some other abstraction?
Yeah, that's an interesting use case. We didn't thought about that before.
I mean, right now I'm able to do it, but I have to re-implement the base predict driver, then the one hot encode driver, and then everything after that.
And what you have somehow is an executor which calculates directly an embedding and afterwards also the classification.
No, different encoders. One encoder only gives you the embedding that you can use to do the similarity search, and the other encoder will generate the encoding and use that encoding to generate the tags. But that second encoder will only give you the tags. The embeddings are useless in that case. I just want the tags from the encoder too, and the base predict driver expects you to use the encodings from the encoder directly.
So basically, you will have two pathways in your flow, right?
Yes.
And when you combine them, you want to use the tags from one flow and use the embedding from the other flow.
Not flow. It can be a part of the same flow. Only thing is
the same. You want to use the embedding from one pathway and the tags from the other pathway, and combine them.
Yes. So I'm able to do it. Only thing is I have to re-implement the base predict driver and everything after that. So is there a better way to do it, or right now I just have to do that?
I think one way to do that would be for the pathway that you for the pathway with the classifier, you can actually drop the embedding after you can drop the embeddings after making the predictions. After using the classifier, you can say, hey, I want to drop the embeddings. And then later you can combine them. You can combine this chunk with the chunk from the encoding pathway.
Okay.
I'm not sure whether it's clear.
Yeah. So the extract talks function, maybe just if I can share my screen.
Yeah, sure. How can we do that?
Can you see my screen?
Yes.
Right. So right now I have this classifier that I've created, a custom classifier. But this classifier actually requires the documents, and BasePredictDriver expects the input. Yeah, over here it expects that the embeddings are already passed in, right?
Okay, for perhaps the first comment. So on executor level, we usually don't want to handle documents, but only somehow the content of the documents. So the driver's job usually is to unpack exactly what is needed from the document, not to hand over complete documents.
Okay.
So that's the basic somehow paradigm that we usually have and that we follow.
Yeah.
So ideally, then you're right. What do you need from the document somehow for the classification? So
Just
which?
Just the text.
The content somehow.
Contents, yes. So yeah, this is what I have done. I've just created a custom that inherits the base driver. The apply all function has this. This is only different because here I don't take in the embedding. Instead of dropping, I have just implemented a new driver to do that.
Yes, I think that's somehow what is needed in a custom somehow driver which unpacks something different.
Yes. So I mean, I was just asking if this is the right way or is there a better way? So
I think for now that's the way how to do it, but it's a fair point that it might be so for this prediction driver that we might want to make it configurable in the future. Someone can say, okay, give me either the embeddings or the content or whatever needs to be unpacked.
Okay.
But there we have to have a look. But I think for now that's the way to do it.
Okay. Thanks.
Anyone else? We're having some good questions today. Thanks everyone so far. But yeah, the more the merrier.
There's something in the
Keep them
chat.
coming.
There's something in the chat.
Something in the chat. All right. Oh, nice. Okay. So we've got Stefan asking, what would be the recommended way of using Jina for a questions answering task? So not just document search, but also dense span search inside a paragraph. So that's question one. Does anyone want to handle that?
What would be?
So in the hack week we had before, I have seen people using somehow the retrieval only question to question, but that's exactly what you don't want, right? You want to somehow have a question and also look in paragraphs of a text without another question where you already know the answer to. Somehow you don't want to see question similarity, but really finding an answer. Is this correct?
Yeah, yes, exactly, yeah.
Yes. So I only can tell, so I haven't done this myself. I can only, if someone else wants to jump in, please feel free to unmute yourself and answer. Otherwise, I will start. So I've seen people doing something similar to the multi-resolution lyrics search, that they somehow split down the paragraphs in sentences or chunks, and then somehow see similarity between the question and the answer. But the problem is that question and answer might be not too similar from if you use a simple text embedding. So that's what I've seen. I'm not sure how well it performs. I have never tried it myself. If someone has a better idea for this, then please jump in.
Yeah, maybe you can clarify. So after the retrieving stage, so basically in our design, after retrieving, we will do ranking on from different perspectives. Would you give us more specific use case? What is the outcome after the retrieving stage? It's like are we talking about the question? Are we talking about the questions? Then we can easily do the text matching, or we want to extract the answer from bunch of text.
Yeah. So what I have in mind is, for instance, running the retriever first to retrieve, I don't know, 3 or 1 most relevant document, and then running a dense search inside the document, or the most relevant document, or the most relevant paragraph inside the document, to select a span, a short answer that would resolve, let's say, the initial query. If the initial query is in form of a question, so not just text similarity or distance between the document and the question, but actually a span inside the document that would say that would resolve the initial query. I was wondering if is a recommended way to integrate this in the Jina architecture as a flow, or as a
definitely you will need you need a flow, and in that flow you will have indexer, and after indexer you need a ranker to do that job. And currently we don't have such kind of ranker in our Jina hub. You might need to implement your own ranker to do this.
Yes, I think that the problem here is, so usually when we do text matching and we have we somehow get the first similarity between the question and all the documents, and we find some of the relevant documents and want to go then drill down. What we could do is, when we have another index where all of the smaller parts of the documents are in, make again some of the matching, but then with a filter to only match somehow the parts of the document that you have had before. Such a filter is not yet present, so we can't do such a filter yet. A second possibility would be, since the amount of text that you have somehow, or the amount of embeddings that you have then for just the parts of the document might be like in hundreds or something. So I get wild guess around 100. You could on the fly then calculate, get these embeddings of the chunks somehow from a key value indexer, and then do the matrix multiplication in a new ranker. And then you would have to implement a ranker which does exactly this matrix multiplication on the embeddings of the smaller pieces of the document.
Yeah, okay, thank you.
So, but we don't have this use case yet somehow, so don't have an ranker which would do exactly this. But it's an interesting use case, and then, yeah. So to say, okay, we want to drill down further more. We always thought about this problem the different way around. We find for our question, let's say 1,000 sentences which are most close, and if we found then take the document where the most relevant sentences are in there, and somehow sort it the other way around. And when you have a document where in this document there's one paragraph or one sentence which is really highly relevant for this question, then that might be more relevant than another document where you have 10 sentences which are somehow related to this question. But if you have a document where you have 2 or 3 or 4 sentences which are highly relevant to this question, that might be the most important document. So we always thought it from this way around, that you somehow do the first retrieval not on a document level, but rather on a sentence level, and then bubble it up to the document. That is our understanding of the whole of this problem and how we would approach it. If you do it the other way around, it would be interesting to see somehow the quality, which approach is better, coming from the sentences and go to the documents, or coming from the documents and go to the sentences. Because when you say you first get the documents, that means especially when you have longer documents, you need to grasp the whole concept of the document already quite well in this one embedding, where you need to get the embedding of the query in the same dimension as the query of a whole document. And there, I would expect that it's rather hard to find a really specific document. You will rather more or less find a lot of kind of relevant documents. But to be honest, I've not tried it, but I'm really curious about the results when you try to benchmark these two against each other.
Yeah.
Yeah. Okay. Thank you. I will study more the Jina framework and try to see how this can be done. And in the meanwhile, also keep up with what is going on in the community. I'm just starting with Jina, but this is the use case I'm interested in. Yes. As I learn more about the framework. Yeah.
Look at the multi-resolution lyrics example. This is somehow the other way around that we until now envisioned as a solution for this question.
And I think,
thank you.
Sorry, go ahead.
Yeah, for the ranker, I think you can check out the Levenstein ranker. To my understanding, you want to compare. I mean, for ranking, you actually want to use the text from the retrieved document and the text of your query.
But especially in Germany, the text might be completely different because you can mix around sentences and still have the same meaning. And then you have a high edit distance, but they have the very same meaning, the same sentence. So that might work, but I would be careful here.
No. What I mean is like you don't need to go to the driver level. You can focus on the executor level, and Levenstein is doing similar thing, but definitely you need something else beyond Levenstein. Yeah.
Agree.
Yeah. So working. I mean, when you're working with Jina, actually you're we are expecting in 99% use cases, you don't have to touch the driver's level. And if you really want to touch the driver level, just let us know, and we will check out the use case. You just need to implement your executors, and that's all the story.
Yeah, and if you have any questions or want to follow up on anything, Stefan, you can just join our Slack, slack.jina.ai, and talk to us all there.
Okay. Thank you for all the answers. I think I will join. Yeah, definitely the channel and follow up with any details.
Good stuff. Looking forward to seeing you there. All right. Anything from anyone else? Saima, do you have any more questions?
No, I didn't study, so I didn't have any more technical questions. Sorry about that. It's just like, yeah, that was a like I just know that last night. So
Okay. Yeah, maybe one comment back to Sama. So as for your question, you're asking whether we have our own algorithms, because you said we want to compete. I mean, if someone use no one want to really use the pre-trained model in the real use case. Well, actually, the one main kind of one analogs we usually made is say when we're building Jina, you mean Jina is actually a TensorFlow for search. So basically we're building a framework that enable people to build their search system. So it's I mean, for us, at least for the current stage, it's not our focus to have kind of a dedicated model for the specific use case or come up with a fancy encoder that can encode everything. So this is not the focus for current stage. And currently we are mainly focusing on building the framework so that it's a universal and complete enough that people can build whatever neural search system in their use case. And while in the future, definitely we will consider to have dedicated AI engineers that focus on building multimodal and cross-model algorithms, so that people can make a more general multimodal and cross-modal search engine. And another direction we would like to go in the future is that for the vector-based, I mean, for this neural search system, the core part is the vector database, and now they have files, and so no matter you are using fast, annoy, or the others, the core algorithm is the approximate nearest neighbor algorithm, and there are a lot of algorithms that in the research in this direction, and in the long run, we definitely also want to make our contribution in that part. Yeah.
cool. Thank you. That is a very thorough answer. Thanks.
Mm-hmm.
Good stuff. Any more for any more?
I had a technical question.
Fire away.
Yeah. So regarding document traversal, when we have matches, and as we go down the level of chunks and matches, is it assumed that if a match corresponds to a particular chunk, then for that match, if we treat that as a chunk in itself, the chunk for which it matched, that is also a match for this chunk. And using that, like as we go down the levels, as we split the chunk further into chunks and matches, do we have a sort of a mechanism for tracking at what level these matches also got split? Like there must be some proximity that we keep while breaking down, so that we don't have to recompute the matches for the chunks as we go down the recursive levels.
So I think we have to now consider two cases. One is the indexing, where we don't have usually any matches at all, where we just somehow go into chunks. And let's first keep it saying this is a more simple use case. There, when you break down chunks and you create a new chunk, it will and add it to another document, it will always get the granularity of the other document plus one. So you somehow have an implicit depths, some granularity depths at each document. Each document knows on which level it lives. So that's the answer for indexing. So yeah, whenever you index a document and in a key value indexer, the granularity will be stored, and when you look it up later on, you know the granularity. And you also know the parent document. So when you know where the parent document is stored, you always can get from document the parent document. That's some of the first thing. And now matches in the end are just artificial edge or artificial link that you set. But there is no implicit, when you have a match of something, implicit knowledge, okay, this query chunk has a match. There is no implicit knowledge that this chunk also knows anything else about this match, some parents and so on. For this, you always need a ranker, which then, when the match is not on the granularity level 0, which means the highest level, but you want to reach the granularity level 0, you need a ranker which bubbles this up. Okay. And for this, we have a ranker which does this somehow. And then it's a question, should the bubbled up result belong to the chunk or to the parent of the chunk? Somehow, where should it bubble up? And depending where you want to, when you somehow have a chunk and a match, where you want to put the parent of the match, if you want to put it to the chunk back or to the parent of the chunk, you need a different driver. And the driver somehow decides where to put it back.
Okay.
And and that's it. And one thing that we're currently missing is that you can bubble up natively again and again and again. So when a document is of granularity, let's say 3, so it has a parent which has a parent which has a parent. So you're level 3. You can't easily go up the steps. You have to somehow know where the indexer is to get always the parent ID from the next parent. So you can go up one step, but not multiple. This is, I think we have this one ticket which addresses exactly this point, how to easily do this bubbling up, because it might be trivial with just a driver, but the problem is that when this driver doesn't the save of the parent IDs in the parent objects, this knowledge is not stored at the same machine or at the same pod as the ranker, then you have to switch between ranker and driver again. Between 2 pods again and again to somehow always go up one step. And then you can either chain pods, which is easy as long as you just write and read once and then just read things. But as soon as you introduce an update and the delete, it gets much more complex because you need to do this update across several executors, which may need to live on the same machine. So then it gets really not so nice. So when you have distributed, and that's why we haven't solved this problem yet.
Okay. Yeah.
But it is a ticket.
I'm not sure if it's so to solve it properly and in a distributed way. I think it's an epic. Yeah. Just because you have to understand.
Happy to discuss that one. Yeah, no, it definitely will become an epic. I can see this.
Yes.
But it is a ticket right now. I can look for it.
Okay. Any of our other engineers got questions? Oh, by the way, for any of our other engineers who are giving talks in the next few coming weeks or months, we've now got a ring light at the office. And if you feel you need an audience, I'm happy to introduce the newest member of the DevRel team. Spoony will watch you.
I had good
presentation. He will watch you while you're sleeping. He knows when you're awake. He knows everything. Be afraid.
Thank you, Alex.
Yeah, thank you.
Okay, I guess that's a wrap.
Thank you.
Thanks, everybody.
Thank you, everyone.
And we'll see you all next time. And yeah, have a great December. Wow. Merry Christmas.
Thank you, guys.
Yeah.
See you next.
Yeah, see you next year.
Next year. Bye-bye.
Till then.
Bye-bye.
Bye.